All right, so hi Ben, and the rest of the class who's all remote. We'll try and get you on screen at some point, but today we're going to go over the intro to the metal shop, which is an exciting and mysterious world. We're going to talk about some of the metal things and some of the metal tools, and that's exciting, but I also want to make sure that we have some time today to sort of go over the circuit business that came from last week, just to sort of troubleshoot, because your first foray into circuits can often be a frustrating ride. And so I just want to make sure that we get a chance to help talk about successes, to talk about failures, and then importantly, how to move failures into successes, because that is an essential part of being able to do all of the circuit business. And it definitely is something that doesn't give you good feedback. So you need to learn how to listen to a circuit, how to know when something has died, and whether it can be revived or not. So that's a piece of what I want to get to today. But we're going to keep moving forward with our first things first and talk a little bit about the metal shop. So with that, we've got some slides. The basic overview of what we're going to cover today is going to be identifying and talking about metals. And part of this is me as a chemistry teacher. We're going to talk a little bit about the periodic table. It is in this slideshow. And then we'll talk about metal tools, sort of hobbyist level metal tools, and some machinist level metal tools to try and make sense of those two calibers. Not that a machinist wouldn't use the hobby level tools, but just to sort of categorize for the sake of having a discussion about them. Then we'll talk about some of the things you need for working with metal. Then we'll talk about precision measurement and why measuring is often so very hard. And then we'll talk about and brainstorm some starter metal projects. So we're going to head in that direction. We're going to go over things that are happening in the metal shop and things that you can get to in there. And there's lots of good ideas to consider with that, and then we can also sort of brainstorm what would be a good metal shop project. Because the scope on that, I think, may be more constrained than you might initially think, because the stakes can be a little bit higher in that room. But let's talk about what's going on. So first off, if I had two different high schoolers today ask me, because I asked them to define them, what is a metal? And so they had to look it up on Google and just try and identify what is a metal. And the short thing is, there's a lot of them. And so it's hard to exactly pin it down, but a metal is something that's electrically conductive, that is often shiny, usually hard, and in your head you probably have a good sense for what a metal is. You're probably thinking steel or maybe brass, copper, gold, silver, those sorts of things as metals. Those are the archetypical metals. But then there's a whole lot more. There's 118 elements on the periodic table, and this is me, the chemistry teacher. Can't resist to put one of these up here. The periodic table is mostly metals. And so I drew this blue squiggly line just to outline sort of the section of the periodic table that's definitely metals. Then there's this like green region in between here that is the metalloids. There's a whole category for metal-like elements, and if you're remembering your high school chemistry, that's sort of where we're going for this first little intro bit. But all of these sections, they would definitely fall into the metals class. So everything in that section, so that's going to be the things that we know and love. There's Fe, which is iron, cobalt, nickel, copper, zinc, silver, and gold. And silver and gold are maybe backwards from what you'd expect them to be. Silver is the one with the G, gold is the one with the U. All of those metals that you're used to, even some of the weird ones that you've heard about. Calcium is in your bones. It's a metal that's in your bones. Potassium is necessary, and sodium levels are important to get your brain to work the right way. Those metals are important for moving things around between your neurons. All those metals are important parts of you and the body, and the way that they work interacts with lots of the stuff about us. But identifying a metal is often relatively natural. It's a thing that we don't have to think about too much to identify, like that is a metal, but to identify which metal is often a bit more subtle. And so it's just good to know that there's lots of things in the world that are metal. And when you think about just our planet in general, there's a giant iron core at the center of the planet. So in terms of how much of the world is metal, it's a lot of it. There's a lot of metal on this planet that we're a part of. And if you were watching the news this week, they just made a big hullabaloo about some asteroid in the asteroid belt that they got a good photo of that's worth 10,000 quadrillion dollars if you were able to bring it to Earth and mine it for all of those metals. But they made a good point that if you actually did bring it down to Earth's surface, you just immediately shut down the economy for each one of those metals because we'd have more than we'd ever need of them. So it's a fascinating thing to think about metals in context, their rarity, their commonality, and sort of how they exist in the universe, and the fact that all of these heavy elements, they came to us from the blast furnace in the center of stars. Like a little bit of context is always fascinating for where these things come together. But we're going to talk mostly not about like the origin of metals, but how do you use them and how do they fit together. So as we're doing that, it's good for us to describe a few things about metals. And the most common of those is iron and steel. And so there's a whole field of metallurgy that there's no hope for us to even get close to understanding in the scope of this course. But there's this giant graph where you take the temperature in Celsius versus the carbon content of some iron, and that determines what exact flavor of iron or steel you have and sort of how that dynamic works. Then you can think about this in a giant smelting forge sort of scenario where you've got huge amounts of molten iron that you're going to cast into things. You can think about it on the microscopic level where you've got domains and grains that can align or disalign to make magnets, which might sound familiar all the way back from high school chemistry. And then there's the blacksmithing realm, which really ultimately we're not going to get too far into. But it sounds like someone's got a question. That sounded like an unmuted person. A question about this business? I'm in. Is that anybody?
I think someone just joined by phone.
Oh, cool.
Is there a question?
Oh, we don't. Yeah, we'll keep going. So the big thing that I want to point out is that as of right now, blacksmithing has become super popular, like in the pop culture of the world. But as of right now, I don't think there's any real blacksmithing gear at MakeHaven. So that may be a growth area, but we're excited to think about those things. We're mostly going to talk about shaping and machining metals for cold cutting instead of hot forming metals. So that's an important part to think about. But as we get I know there's a kiln that's on order that might be available to do a number of things, but part of that could be heating and cooling metals for a tempering, annealing process as we're working through. And that kiln is probably not going to make it in time for either of our 2 metal shop weeks, but it is something to think about for down the line in the future, for ways that you can work with metals even further. But if we're talking about metals, there's a few properties that are worth commenting on, and one is hardness. Hardness is often a part of our definition of metals, that we think of them as hard materials. And so defining hardness is important. There's even an official scale for hardness, the Rockwell C hardness, or this National Standards Reference Material Hardness Scale, where you can compare hardnesses. And if you did college or high school geology, you might have remembered a hardness lab where you scratch rocks across the stone, and some of them scratch really nicely and others don't scratch at all. Or maybe just the vernacular that nothing is harder than a diamond, that's the hardest material, which means ultimately that the diamond is going to be tough enough that it will scratch anything else that you put it up against. And so whenever you're talking about hardness, it's a relative measure. So it's how much can you scratch something else is really what we're talking about for that. So it's an important piece. It also means when things are harder, there's other implications to that. But having a molecular structure that's really self-reinforcing, that's really self-stabilizing, builds up hardness and makes for harder things, which is often one of the most identifiable parts of metals. Now, there are metals that are super soft, like lead. You can bend with your hand, or if you're talking about gold, the iconic way that someone would test for a golden nugget in an old-timey movie is they'd bite it, because gold itself, if it's pure gold, it's soft enough that with a bite you can deform it. And so there's lots of different things that happen with hardness. For metals, there's some metals that are very soft. There's even a few that are liquid at or near room temperature. Mercury is a prime example of the liquid metal. Gallium is another one that's fun, and it's not it's at least not very toxic, where you can order it, it comes in solid, and then if you heat it up, you can get it to melt in your hand. And so there's some good videos of people playing around with those. Yeah, I don't know. It did a little hiccup. Oh, there we go. We're back? Okay, cool. Cable disconnect. We're back on it. So hardness is an important thing to consider. And as we think about hardness, because it's such a common property to consider with metals, you want to start to think about hardness and softness being on a range. And so as we think about the range of things that are soft and hard, that range has some loaded pieces with it. If you get a material that's really hard, usually the trade-off that you're making for a hard material is that it becomes brittle. I used to have a ring that was a tungsten carbide ring, which was the hardest ring you can get fundamentally. It was a little, it's not necessarily the safest ring to be wearing because they can't cut it off if you have to go to the emergency room. And so it's tricky. But I was told that if it ever broke, it would shatter, right? So a very hard material will often also be brittle. It may be very resistant to breaking, but when it does, it will chip off and pieces will shatter. It can be a very brittle material. Whereas a softer material, you know, you're not as strong, but you get a little bit of motion, a little bit of ductility, some malleability. It will stretch and give before it fails. That little bit of plasticity is often very helpful when you're talking about having materials. And so the dynamic between soft and hard is something that you want to consider when you're thinking about your metals and your materials this week. And then, interestingly, iron and steel is one of the most fascinating on the spectrum because you can actually modulate how hard or how soft it is so that you can get the dynamic that you want. And in a knife, you may even have regions that are harder and regions that are softer. You may want a very hard cutting edge, but the back of the knife to be softer so that it can withstand a little bit of flex. So those dynamics on a very high-end piece of material, you can even play with that dynamic some. But then for a lot of metals that might be used in here, we're going to talk a little bit more on the softer side. Like a piece of brass is going to be relatively soft. Aluminum is relatively soft. There's lots of different metals that we want to consider. And so I made a list. This is a big list with lots of words all on one slide. And so I would recommend that you come back and refer to it if you ever want to. But these are probably all metals that you know and love. There's aluminum, brass, copper, pewter, nickel, titanium, zinc, and then the ferrous metals, iron, steel, and more other steel. So when we think about those, it's important to try and consider each of them and categorize them and think about their properties. So we're just going to work through them a little bit more. And we're going to start off alphabetically with aluminum. So aluminum is a metal. It is a metal on the periodic table. If we went back, it would be metal colored, just like all of the other metals. But if you ask a metal worker, they may not consider it a metal. Sort of like fish is not considered a meat on many menus. It is still definitely got eyes that looked at you if it was an animal swimming around. So I would categorize it as a meat, but most menus will separate fish from the rest of the meat on the menu. And so aluminum falls like in that category of yes, it's a metal, but it's very different from others. So it's a common soft metal. And another thing that's interesting about aluminum is that it's extracted with an electrical process that used to make it very expensive. The top of the Washington Monument's actually capped with aluminum because at the time it was more valuable than gold. Since then, it has become sort of the garbage metal, right? You can make a beer can out of it, of whatever, and then they're disposable, or you get 10 cents for recycling them. So those pieces of aluminum make it very interesting and appealing as a metal. It's also very soft, very shapeable. Aluminum foil works well because you can bend and squish and stretch, and it doesn't break. It's got a lot of plasticity. It's not a very hard metal, and you can cut it with basically a perfectly sharp wood tool. It's soft enough that wood tools work just fine on aluminum, although you may want to do it without the woodworkers watching you use aluminum through the wood shop tools. So you got to be a little careful with that, but it is a soft enough metal that you can cut it. Brass is another well-loved one that's similarly workable in woodworking projects. It's a nice inlay. A brass inlay can add a really nice color. It's that golden doorknob that we probably all saw from houses built in the 80s. The golden doorknob, the brass doorknob piece that if I get a chance, I replace in any building that I occupy. But those are fairly soft, workable. They've got a nice feel. Some people really like the touch of a brass material because it doesn't wick the heat away from you immediately. But it's a blend of copper and zinc. And so copper is the next one on our list. Copper is that orangish color that the pipes, that many of the pipes in MakeHaven that carry around compressed air are using, or pressurized water. Plumbing has been made out of copper pipes for a long time. Since we stopped using lead. In ancient Roman times, they used lead, which is where its Latin term plumbum even comes from. But copper plumbing has been around for hundreds of years, or at least 100 years easily. And it's a well-used material for that. It is pretty valuable at this point. So if you've got an abandoned house with copper pipes, I'm sure you've heard of people going into those abandoned buildings and stripping out all the copper piping just to scrap it and sell it for a little bit of cash. So those are all things to take into account. But it has a very nice look. I really like the look of copper. Pewter is another one if we're going alphabetically. Pewter is a low melting point tin lead blend. Lead, by the way, is toxic, so I didn't put it on the list. But pewter is often used for casting, and a lot of old kids' toys had pewter in them, where you had a mold, and they would cast molten pewter, and you get a fun, like, pewter soldier shape, right? Or a little car that was made out of pewter where they could cast them and then create them one after the other. Pewter is a soft, it's a soft metal. It has a low melting point. Actually, is a in what? Oh, yeah, the Monopoly pieces were pewter at first, right? And then they have stopped because of the lead. Now they're plastic, right? Or no, I think they're metal still. But
I mean, I guess the last time I really interacted with a Monopoly set, I was probably like 10.
Yeah.
So,
Yeah, no, the last time that any of us have played Monopoly was when we were all 10. So if somebody else knows what the current set of Monopoly pieces are, maybe they're brass. I don't know. That's reasonable. But there are lots of metals that you can use. But pewter is one that back when I was in high school, and I think my art teacher at the time knew it was bad, but she had an opportunity for her oldest students to work with some pewter and cast things. So it's a neat metal if you ever get a chance to work with it, although it's probably not on the list of approved MakeHaven things just because of the lead content. And for good reason, right? Lead poisoning is no good. Nobody wants that. Next up, we've got nickel, which is an odd one. It's what the nickel itself is named after. It's the namesake there. And when you look it up, it says it's a hard and ductile metal used in coins. But having something that's hard and ductile at the same time is a little bit paradoxical. If it's hard, it often is not as stretchy as other materials. It might be more brittle, but nickel is interesting in that it's got sort of both of those things happening. Now, for ratings, I'm not sure exactly where that would fall. I would need to do a little bit more research, some legwork. But those were the first two adjectives that popped up for it, which was an interesting combo, I thought. But it is a commonplace metal. Titanium is a very hard chemical resistant metal. It's often used in aircraft. I think its density may be a little bit lower than others, but being especially hard and especially chemically resistant and then a little bit springy makes titanium a favorite. It is harder to machine for that reason, but it is an interesting metal and people often like to have it. It's a premium grade metal, right? A titanium or a platinum. If you have a titanium power supply or a platinum level rating for your LEED certification, that's considered to be even more valuable than gold. And while that may or may not be true about its cost, it does give you a sense of the scale of that metal and its expense, right? Its cost. And then
it's used for a lot of body jewelry.
for fine jewelry.
No, well, sometimes, but for body jewelry, like stuff that will be in a fairly permanent way, like, you know, like
Yeah.
nose rings, belly button rings.
Sure. Yeah, so the comment was, because it's chemically resistant and somewhat antimicrobial, it is used in semi-permanent body piercings. So nose rings and other piercings that are going to be in for a long period of time. Brass is also somewhat antimicrobial to perhaps a lesser extent than titanium. And it's one of the reasons why it gained fashion as doorknobs and other things and other fixtures. Yeah, yep. Lots of these are medically used, and I didn't even try to figure out what the medical ratings are for these things. But many of them that are more antimicrobial or more They're slightly toxic is often how that comes into play, that for a microbial growth, it's going to disrupt that. But they're both, well, so I would need to look before I get too committed to making a statement. Yeah, no. Well, titanium is probably not toxic, but it's definitely antimicrobial. So there are those pieces. Sometimes they do that. Like there are IUDs that are copper, and those are they disrupt the body's process in certain ways, and you can have terrible responses to them if you are allergic to copper. And so the dynamic between a metal and a person's body can be complicated, but it's worth, if you're thinking about integrating a metal in your body, it's something you need to deeply research. Please, no one, we're strongly recommending against making things that you put in your body permanently for these 2 weeks. Don't try that, not under my watch. Next up, zinc is the cheapest of these. Zinc is what's the majority of a penny. And pennies are probably on their way out in the long run because it costs a little bit more than a penny to make a penny at this point. However, zinc replaced copper a long time ago in pennies so that they were cheaper to make. And so if you take a penny post some certain year, I think maybe in the 80s, and you cut a penny open, which you can totally do, you'll see that the outside is an electroplated copper on the surface of mostly zinc. And so it's and zinc actually will boil away really readily with an acid, or not boil away, but dissolve into an acid. It'll make a salt really nicely and then leave. So a fun chemistry experiment that I would do with students is to cut a penny open so that it's got access to the zinc and then leave it sitting in an acid, a weak acid even, for a few days, and it will dissolve away the zinc, and you'll have the copper husk of the penny left over. A very clean Abe Lincoln looking shell, which is kind of neat to see happen if you want sort of a in the background project going on your counter for a while. So those are all different metals. Also, zinc is used for a galvanized coating. So if you have a metal that you want to keep from rusting, if you have iron or steel that you want to keep from rusting, you can have a galvanized nail, and that zinc is going to form zinc oxide, but that's not iron rust. And iron rust will weaken the material over time, but zinc oxide is fairly stable as a surface material. You're passivizing the metal, and so that can be useful. But what's up?
Galvanized steel that has zinc on it is super toxic to weld.
Yes, and so good point to make is that galvanized steel is super toxic to weld. So if you're going to be thinking about using zinc-coated galvanized steel, and you're thinking about welding at the same time, just stop. You'd need to grind off the zinc galvanized layer, and even then, still probably not worth doing if there's another steel source available. You can find some other steel to weld for sure. There's plenty of it. So if we're taking those metals into account and all of their different places, it's good to go through the ferrous metals. And so iron's elemental symbol is Fe. And there's a whole lot of, it's a very ancient metal that we've known about for a long, long time. There's tons of it across the planet. And so in its more raw form, you've got iron with a higher carbon content often in and amongst those iron atoms. And so that is super abundant. You can find it digging things up. It's what many asteroids are made of out in space. It is the final material that many stars will make inside the star's actual atomic fusion core in the generation prior to our sun. And so it is a heavy, dense material that is a super common metal in Earth, and it's something that's used very broadly. It's also very workable, and you can change its hardness, so it's super common. Steel is then a derivative of an iron product, and so if you can reduce the carbon content in your iron, then you get steel. And there's many, many classes of steel for exactly the right content, that big graph. There's entire fields of study of understanding that graph where the temperature and carbon content came together, where we had that blue backing or the blue-green backing on the graph in this slides. But just to break it into two categories, there's cold rolled steel, which is a softer steel. This is one that's still plenty hard for almost all of our applications. And so a cold rolled steel or a cold steel is going to have a low carbon content. It's fairly soft. It's fairly workable. You can cut through it with the tools in our metal shop. If you're looking for something to work with and you don't want to use one of the colorful metals on the left-hand side, you want to go with this cold rolled steel. And this is something you can pick up at Lowe's, Home Depot, any hardware store. There's lots of different places around where you can get metal like this, where you can get cold rolled steel, and it's super easy to work with as a material. And then there's hardened steel, which is then harder to work with. Because it has a higher hardness, you're thinking about hardened things would scratch softer things. And so when you think about our cutting tools, if you have steel that's hardened enough, it may be that our cutting tools can't actually cut through it. And so then if you make that attempt, you're going to do some damage to the cutting tools. And when I was badged on many of the things in the metal shop, which wasn't super long ago, the main theme is that when asked what can you cut with this tool, almost all of them don't cut hardened steel, right? And so hardened steel is something that you'd need a special situation to make work. And probably what would work better is if you had a cold rolled steel, and then you go through an annealing or a tempering process to get it harder once it's shaped into the form that you want. So those are all pieces to take into account when considering this, but you've got your iron-based metals on the right, and you've got your non-iron metals on the left. It's good to sort of keep them in different categories and know that a metal worker may have really mastered the ironworking and think of the rest of them as sort of like fluff to put on the side. Or special niche applications where they're trying to find a medical application, so they use titanium, or they want a fancy-looking doorknob, so they use brass. They have a more niche use than sort of the general purpose iron that's going to be super commonplace. You know, it's the base of the tables that you're using right now. It's a really common metal. There's entire cities, industries based around it.
Ruby said to repeat that?
Oh! Steel is the most popular metal and probably the most workable one. The aluminum, brass, copper, pewter, nickel, titanium, zinc list is got more specialized applications. And so there's a big industry around iron and a smaller, each one of the other metals has a smaller niche. They're more rare, they're going to cost you more. And so those are all things to take into account when you're looking at projects and project design. But this image down here in the bottom right is too small to really see, but it's a link to McMaster-Carr. And so I'm just going to pull this up. This is one of the many, many places where you can source your metals. I like this one just because they're so clear about here are the different metals that we have to sell. These are where you can buy them. This is typically one of the more expensive routes to get your metals just because of shipping and all those sorts of things. I actually used to live right next to this. So it was super, I could walk in and pick up my orders from McMaster-Carr, which was pretty fun in Cleveland. But the ordering here is actually really good. So if you wanted particularly, if you wanted aluminum, you could come into here and then you can choose what kind of aluminum do you want, what shape do you want it to be, do you want a hex tube, do you want all those other tubes. You can get exactly what you want from McMaster-Carr. But for all of that, you pay a little bit of a premium. It's such a nice ordering website though, and a giant automated factory that is bonkers. So in any case, heading back to...
Can I ask a question about aluminum? And it may be that I'm jumping ahead.
No, go for it.
So I didn't know that there were classes of aluminum. When I was researching for what I wanted to make, I discovered that there's different grades if I'm using the word right.
Yeah.
So that sort of surprised me because I didn't know that, and I'm wondering if there's if that's a consideration in all metals, or if it's just aluminum, or if we want to make something that's food grade, considerations like that, and how we go about self-educating on that.
Yeah, no, that's totally a thing for most metals. You can have slight variations in the blend of what's mixed in with the core of aluminum, and so just a little bit of this or that is going to change the blend, and I have to look it up every time. I don't have a great, I'll spend a little energy this week trying to find a good reference page for us all to consider. But for most of aluminum, the aluminum that you would walk into Home Depot or Lowe's and buy, it's going to be this multi-purpose aluminum. And then there's architectural aluminum, which is, I think, just a little bit higher quality, a little bit stronger. But really, those pieces I would need to look up per metal. My metalworking projects have not gone so deep that I needed to make that distinction. And most of the people that I know that have a natural sense for one versus the other, they know it for the steels. And so if you're looking through those metals, right, there's steel, stainless steel, and tool steel. Even in McMaster-Carr, they break them out into 3 categories. And so you've got multi-purpose low carbon steel, easy to machine carbon steel, high strength steel, 1045 carbon steel. There's 1040 steel. There's all these different ranges of steel that you may want to consider, and that can be fairly overwhelming. However, there's entire like metallurgy fields where you really get to understand that. You can get a degree in understanding what metal to use and what purpose. So don't feel like there's any world where you're going to understand all of that this week or next week. But there are the like multi-purpose metals that you're going with. Those are the ones that you want to use. For food-based applications, there's some good experience, but I think that I would again, no inserted body metals, no parachutes, and no food grade metals would be a good piece of advice for what's going. But generally, like if you wanted to use a stainless steel grate, like that's what gets used in a grill, a stainless steel grate like that you would set your steak on or burger or whatever. And then there's lots of other options where you can do a little bit of research to get there. But I would generally say like let's try to make sure that we're not worried too much about the body dynamics of these metals. So yeah, sorry, that's a little bit less helpful of an answer, but I would just stick to the multi-purpose and easy to machine grades for what we're doing for the next 2 weeks. You don't want to go too intense. But I mean, like all of these are available, like impact resistant A516 carbon steel. Those are all available things if you wanted to pick them out and look through them all. The main goal this week is really to get a sense for those machines and sort of their distinction from the wood shop ones is what I wanted to get to. So yeah, that's a good question and one that we can explore more. I was hoping to cover that a bit more next week as we try and process this a bit further. But if you're going to buy these things, sheets, pipes, tubes, rods, bars, blocks, or like a square tube, particularly for steel, you'll need to find a vendor for those. McMaster-Carr is the most options vendor that you're going to have. It's going to take a couple days to get here. Their shipping is good, but it still will take a few days to arrive. You can pick up metal at any big box store where there's usually a little section off in the corner. Buy all of the hardware for doorknobs and hinges. There'll be a section where you can buy bars or rods or threaded rods, all of those things. Usually you can get at Lowe's and Home Depot, aluminum and steel pretty easily. The multi-purpose steel, that would be soft enough to cut with like home-based tools, which we would certainly be able to cut that here. And then there are some metal shops around that do sell. There's a list I know that MakeHaven has that maybe someone could drop into the chat between Kate and JR. I'm sure that one of the two of you know off the top of your head the name of that. This is where me being new to the area still need to learn that. But
we could have that list again. I know Kate gave it to us, but it's kind of lost somewhere.
yep, yeah. If you could drop that list in the chat again, cool. Oh, great. JR did. So then there's the list of the local buying options that are available there too. So let's talk about the metal tools. What are the tools that we have for us in the shop that I would say are super approachable? These are things that will make sense very early this week as you're trying to do a project. These are great tools to get your hands on, just to get started with. And I would say the big distinction is that they are leveled up in terms of power from the wood shop tools. So every one of these machines is very similar to their wood shop counterpart, but the motors are bigger, the gearings are more aggressive, and there needs to be more power to make it through the metals. And so you've got a different dynamic that happens there. In the wood shop, sometimes you'll hold down your metals, and you'll find that with all of these metalworking tools, there's going to be clamps either built in or slots to put a clamp right there. Because if you're working with wood, you are only slightly softer than the wood. But if we're thinking about the softness hardness scale, the metals are all much harder than you are. And so if a piece of metal goes flying off of one of these cutting machines, it will not hesitate to go through you if it needs to. So you've got to be a little bit safer and a little bit more conscientious. It's why this came after all of the woodworking stuff, just so that you had a little bit of practice with the woodworking tools. But lots of the things are the same. So it's sort of analogous to the compound miter saw. You've got the metal chop saw, which is this guy over here. And so it feels very much the same as the compound miter saw. No compounding that way, but you on side to side on the saw, but you can definitely tilt the workpiece. The fence is more adjustable, but the saw moves in a consistent pattern. There's a smaller 6-inch cutoff wheel that's like a mini version of the same deal. It has an angle grinder cutoff disc that it's using to make that cut. And then there's bandsaws. So bandsaws also work. What I've got depicted here is the horizontal bandsaw, but the vertical and horizontal bandsaw, they both will work pretty much the same way as the bandsaw in the wood shop. The vertical bandsaw is very, very similar, but you do have to think a little bit about about getting material on there so that you've got at least a few teeth engaged with your piece of metal. So it's really better for thicker metals rather than sheet goods. Sheet goods you want to snip with scissors or shears, that's the word, because a thin metal you can often cut with real heavy-duty scissors. And so you can get some good work there. A bandsaw is for slightly thicker stock, 1/4 inch and a little bit higher. You want to have a few teeth engaged when the bandsaw blade is going through. And you want to have larger teeth for aluminum so that you can scrape out that material. For steel, you're going to get smaller teeth that nibble their way through. And so the blade that was in there the last time I looked was a steel cutting blade. The teeth are very small. If you wanted to cut aluminum on the bandsaw, you may have to change out the blades. So you'll want to take that into account. The horizontal bandsaw, if you can get a chance to get badged on that thing, it is a dream. It has a clamp to hold the workpiece and an automatic feed feature so that if it makes a cut, if you would like to have pieces of metal cut, it will cut your piece and then it'll retract the saw out of the way and then push the work forward until you get a second and third and infinite number of exactly identical cuts. It's an amazing tool that it's able to do all of that all in one go. It's super high-end. It's great that we have it. And if you were trying to build a table with 4 identical legs, it would be the way to go. You set the length that you want it for the first leg, and then it will cut 3 more just to perfectly match. And so you can get a dynamic like that to work really well. It's great for building architectural pieces from square steel tubing because it just cranks through the cuts for you. And you can be mildly paying attention while you're letting your work go through the process. So that's a neat one, that the horizontal bandsaw is an option that's a little bit automated. It's not doing any dynamic choices or making movements on the fly, but it has a cycle that it runs through automatically of clamping and moving the work for you. There's also 2 drill presses, and these drill presses are a key example of bigger and more powerful, just like the bandsaws are. And they have larger motors, higher gearing, faster speeds, and they're able to, but they're still doing the same thing. They're drilling a hole through your workpiece. Your workpiece you should definitely have clamped in the metal shop, but they do functionally the same thing. The bits are going to need to be a little bit more aggressive. We don't mix bits from the wood shop room and the metal shop room. There are metal shop drill bits, and if you would like your own extra sharp one, you can totally do that. But they work in largely the same way. So if you have practice with a drill press in the wood shop, it may be neat just to get the analogous badge to make that comparison. Then there's an interesting tool, the shear brake and press and slip roll. And that one is relatively easy to do. It's nice, approachable. It's all hand operated. So it's not a power tool, but it lets you cut, bend, and aggressively bend sheet metals. So you can get shaping that happens and cutting from that one tool. And we'll look at it again. I've got a picture coming up in a little bit. There's also other tools, sort of handheld, a metal angle grinder. There's a whole class of pneumatic tools, which I've got depicted across the bottom, where you use air to power these tools instead of electricity. It can often be helpful, especially if you're running a coolant over something that you want to cut, to have air powering, so you get an air line and you drive these tools that way. There's pneumatic shears, which are really interesting. They'll make cuts for you, so all you need to do is drive them forward in the direction that you want the cut. You have a little bit of play. You can make a bit of a turn with that, but it's air-powered cutters, which are a neat tool to have if you're cutting up sheet goods, is really good for that. And then there's also plasma cutter and a water jet cutter. Those are totally things that are available in the metal shop. My first metal badge in MakeHaven was absolutely the water jet cutter. And if you have experience with vector design, it can be a good place to start. If you're already a pro on the laser, you're already a pro on the vinyl cutter, it can be a fun one just to get in there and try if you wanted to cut materials that way. And a neat thing about the water jet is that fundamentally it can cut anything. Maybe not wine bottles successfully, Kate, but it does cut lots and lots of things, and it does so really nicely. It can cut metals, it can cut stones. Sheet goods, you have to be careful to not get too much wobble with those things, but the software for that is a bit wonky, but it's a neat one to try. It's good to get a badge on if you want. The badging process can be a little long, and you'll want to reach out to the person who is doing that badging pretty quickly if you want to get that badge to happen. But it's a fun one. And we'll cycle back to that when we get to computer-controlled cutting, like the section of the course. But if you wanted to jump on that right now, you totally could. A plasma cutter is also an available option. I would throw it in that welding category, though, in that it's a hot tool. It's a hot cut. But it is a totally accessible way to cut up metals. So this is the cutting metal section of tools. Then we've got grinding and shaping. So one of the things that's different about woodworking and then your metalworking is that in woodworking, you'll sand things or you'll plane them to take off little bits to get a smooth finish, to get something that looks nice. And in metals, you don't have a fibrous grain structure. Metals are just a mesh of atoms that are all interrelated. We're going to look at those metallic bonds in a minute. But those intermeshed pieces, instead, they get ground off. And so you're taking them off in chunks. Or if you make a cut with the bandsaw, you'll have those pieces that don't sever a fiber, and so they're still attached by a little bit. You'll get burrs on the end of your cut, and those burrs can be very sharp. If you did any computer maintenance back in the 80s, the computer cases of old, those big, like lightly off-white tan colored computers that you maybe saw sitting in your parents' home, those had inside very often not deburred innards. So they were made out of sheet metal that was folded, but it was often pretty easy to cut yourself on those because they hadn't softened the edges. They hadn't thought that people would be inside maintaining them. They thought of them more as appliances. And inside of a microwave, that's still pretty true. They're not really meant to be serviced by somebody who doesn't know what they're doing, whereas now there's an entire hobby computer building sector where they expect people who aren't aware that they're going to cut themselves to open those things up. So in any case, you make a cut on metal, and you often get a sharp edge. So there's an entire category of tools that you can use to soften those edges, to break the edges, or to shape things without needing to make a cut. And because metals will hold their shape really well, that can be very useful. So the first section of these is for grinding. So there's the angle grinder. You've got an angle die grinder, which is going to just sort of spin and make some cut. You've got a die grinder. The angle grinder in general, there's an electric one that you can use to cut and sort of remove material. The grinding wheel is in the top center here. This guy is a wheel that spins. From my childhood, I remember lawnmower blades being sharpened on that thing, and that was it. But it's useful for many, many more purposes than that. I saw JR making some lathe tooling with the grinding wheel just yesterday. So those grinding wheels can be broadly useful. There's also belt grinders. Those are sort of like sanding belt sanders, but a little bit more aggressive. They're going to remove material. They're going to deburr things. It's very important that you think about your workpiece needing to be angled in the right way so that it's pointed downwards. Sort of similar rules to how we saw with the belt sanders, that you want to hold your work in the right way so that it doesn't get pulled away from you. And then there's also the brake. The brake is this thing over here. This is sort of a big clunker, and there's this handle over here on the right-hand side that you turn manually by hand. And so turning that handle is the power for the tool, which makes it one of the safer ones of this group. Some of them, they really have the ability to do some damage because they're powered and the motors are aggressive. In the case of the shear, press brake, and slip roll, you're the one in charge. So if you feel it start to pinch, you stop, and you're much safer. So there's lots of opportunity to do some fine-tuned shaping with this machine, and it's really three things in one. It can cut a sheet metal, it can bend it for a crisp edge, and it can do a rolled bend. So all three of those actions are possible with this tool, and it's a neat one for building sheet metal geometries. And that's totally a thing that you can do sort of on the fly, to take a piece of sheet metal and shape it into something fun and interesting, or it's something that you can have a definite plan for, where you design it out in CAD and work from there. And so we'll talk a little bit about those options a little bit later. There's also the Arbor Press is an interesting one. It's this guy down here in the bottom right. And essentially it's got a big gearing on a wheel and then a lever arm so that you can apply a lot more force than you would be able to by hand. So if you couldn't bend a piece of metal, you could throw it in an Arbor Press, and the leverage and gearing will help very much in your favor, let you be able to bend or deform something. Kate used it to crush a piece of plastic. You can apply lots and lots, I'm tempted to say a ton of force out of an Arbor Press, but I don't know the exact number. So it's a lot of force that you can get out of those things. They're a great way to really squish on something if you need to. Other good tools are the English wheel. And so that's this guy with the flame detail. The English wheel is a neat one because you can press materials against two wheels. And based on the contour of those wheels, you can sort of stretch and squish a sheet good so that you get an interesting shape. So imagine building custom car parts where you want a nice gentle curve, you want a swooping motion across it. You can use the English wheel to sort of work that shape into a sheet metal so that you get a nice easy curve into things. And sort of in that same vein, there's the stretcher shrinker, which is just above. It sort of nibbles its way through the metal, crimping it in just the right way that it makes it either a little bit bigger or a little bit smaller so that you can get a gentle, detailed curve across the surface. But mastering the dynamic of both of those is definitely something that it would take a long time to get used to. Learning the dynamic of how exactly do you use the wheel, where do you move it, how does that go, is going to take some time and some finessing. So it could be great to practice and just take a piece of flat sheet metal and turn it curvy for the time being. But if you wanted to build curved metal art, it would really take a while to get used to bending and moving on those tools. Then there's the bench grinder. Is another one of these wire wheel bench grinders sorts of deals where you've got essentially a giant motor in the middle for both of these things, a large motor in the middle that's spinning the two wheels on either side. You can change out those fittings. Sometimes they're grinding wheels, sometimes they're polishing wheels, which is really fabric with a rubbing compound. And then you've got wire wheels that can also take off little bits of surface material and wear down the wires over time, but also take off the surface rust on a piece of metal. So if you have something that's rusted, but you'd like to restore it, I saw somebody do that with plumbing just yesterday. They had a rusty pipe fitting that they wanted to reuse for a decorative piece, and so they just ran it through the wire wheel to remove all of the rust by knocking it off one piece at a time. And then bench grinder and polishing wheel, they all fit into that category, and they really work well together as a whole unit. There's several different wheels that you could take and put on and off. As a kid, we had one of these like motor pieces, but you could switch out what wheel you wanted to have on either side. Now, in MakeHaven, we have enough that you don't need to swap out those wheels. You can just walk up and use the one that you want, which is really helpful.
What is the distinction between the grinding wheel and the bench grinder?
So that is one that I think that they show up differently in the list of MakeHaven things, and I was actually wondering that myself when I was looking at this list this afternoon. But the bench grinder is, I think there's probably not much of a distinction.
Yeah, I mean,
They're the same thing. Unless I'm mixed up, am I? No, the grinding wheel and the bench grinder, I think I just put them on the list twice. That might have been the case. There's several of these things that have adopted multiple names. Naming in metalworking, especially when you get into the machinist realm, there's often many, many names for things. Because they were developing this technology at a time when people loved to categorize. So lots of these things have multiple names. I probably just put it in the list twice. So if these are for cutting and then we have grinding and shaping, the next one would be to fasten metals together. And so there's lots of different ways that you can do that with fastening tools. There's tap and die tools where you'd cut threads into a piece of metal so that you could put a screw or a bolt into it. And the tap and die are the two sides of that. Think about one would make the threads on a nut, and one would make the threads on a bolt, and those two mate together. So the tap is to put the threads into the nut part, in the sort of the female end, and then the die is to cut them on the screw, if I'm getting those right. But they're almost always a set to put together. So a tap and die set is a really common thing to have, and we definitely have some in the metal shop. Then there are machine screws, which have those smaller threads shown here. These are bolts or machine screws. Those have finer threads because then like a wood screw, You've got down here another example of a screw. So this would be a self-tapping screw. And the thread pitch really is something that's important to take into account. Thread pitches were standardized a long time ago when the first lathes were being built. It was decided and very nicely kept to a standard. And so there's a 60-degree pitch on a thread is pretty universal. The threads per inch varies quite a bit though. And so you've got these tighter pitched ones are what I would call a machine screw in that category. And then you've got bolts that sort of fall into there as well, where your threads are much finer. And in metals, the material's strong enough that it can take all of that strain on a smaller thread. A wood screw has a larger thread because it needs to have a better grip further out into the wood so that it's got a little bit more compression of those fibers to get a similar amount of strength. And so you've got those things that you want to take into account when you're thinking about the different types of screws and bolts and how do you make sense of those. There's also a really common size is a 1/4-20, which means that it's a 1/4 inch in diameter and then 20 threads per inch on the listing. And so you'll often find, if you're looking at buying the right size bolt, them listed with those 2-part names, 1/4-20 or 440 or 1032, where they have the first number refers to the diameter of the screw or the bolt, and the second number refers to the threads per inch. And so you've got a common one is 1032. A number 10 screw is a 3/16 diameter screw. And not that you would need to know that directly, but it's just a fun factoid. A number 10 screw is a 3/16 diameter screw. And there's 1032 and 1024 thread per inch screws where they have the same diameter, but they have different threads per inch. So in the 1032, the threads are much closer together. 1024, they're a little bit more spread out. And so they have different thread counts because they might be useful for different things. 1032 is going to be a little bit finer, and it's going to need a little bit more control to make it. 1024 is a little easier to get in and out. And those threads are often, they're often the same thickness. It's just how much spin and how much grab do you want. And those are things where you've got to really get down to computing which one of those is best for your application if you're worried about it down to that fine detail. But for our projects, you should not worry about those finest details. For us, a nut and a bolt, if it's got the right thread count, is often the one that you want, more than worrying about picking between two options like that. We just want to make sure that they match for a lot of our projects. So what I've come as a general rule is to have sort of self-standards. If I can use 1/4-20 for an application, I'll do that. It's a really common one. It's even so common that it's the mounting thread for the bottom of a DSLR camera is a 1/4-20. So if you have a 1/4-20 threaded rod and a nut, you can build yourself a camera tripod, which is fascinating that that's even an option for all of us. So those are all sorts of things that you can play around with and consider if you want to really get into the weeds on those thread counts. This is a nice little graphic, though, to try and consider all of the geometry that it took to standardize nuts and bolts as a piece. And so there's lots to consider. The inner thread, the external thread, how do you pitch those? How do you cap off the inside threads so that they're not razor sharp on their edges? How deep do you need the cove for it to fit into to be? All of that geometry is important to think about if you're cutting your own threads. And I linked to video in the page for metalworking where you can watch Adam Savage go through the process of making a nut and a bolt from a raw piece of brass on a metal lathe, which is actually a great watch. It's pretty long. It's a good like in the background video to sort of to listen and watch him struggle through that account. Not that you'd want to hop onto the metal lathe this week per se, but it's just good to watch somebody work through the process of learning a new skill. Then if you want to avoid threads and pitches and all that altogether, rivets are a great way to hold sheet goods together. A rivet is this yellow guy in the middle here, and it's a little post that is down here on the end that's a bit thicker, and then this top. You've seen them in metals before where they come sticking across the top, and they look kind of like screws, but they don't have anywhere to attach. A rivet gets placed through a pre-drilled hole in 2 sheets of metal, and then that long, skinnier post is pulled until the bottom gets deformed and squishes the 2 sheets together. So a rivet like that is going to squish 2 pieces of metal together, and you can use rivets like that to make a permanent connection between 2 things. You can drill out the rivet later if you really need to remove it, and so in restoration work they'll often do that where they drill where the rivet is and remove the rivet itself. because it's often made from a softer material like aluminum in order for it to work. There are steel rivets, though, if you needed a real aggressive rivet. And then I even in my bag have some threaded rivets. So you can put in a rivet that has threads on the inside so that if you'd like to use it to fasten 2 sheets of metal and to put a thread in, you can do that. So I have some 1/4-20 tapped threaded rivets, which can be useful also if you want to put a thread into a piece of thin sheet metal. So there's lots of options for how to connect things, and we've still got more. There's spot welding, where you can take and use a high current to melt some metal together. Spot welding is sort of the easiest welding to do, because you just take some big copper contacts and you pinch them together right onto what you want to weld. We can grab the spot welder in a minute and actually take a look at it. But it just passes a lot of electrical current through the metal and fuses those 2 pieces together. It's how they make custom battery packs in like RC cars and those sorts of things. Then there's also full-on welding for steel. There's brazing for aluminum. And then there's soldering and sweating for like copper pipes if you want to get your copper pipes put together. And so lots of people, if you're doing at-home plumbing, which I have in the past, sweating together copper pipes is something people get intimidated by, but it actually goes pretty well. You just heat it, you put in some flux, and then you heat up the copper pipes, and the solder will wick in very much like a little solder joint on a piece of electronics. You can do that with large copper pipes. And this little example piece of copper down here in the bottom has a brass fitting, and then you can see all of this silver is from the solder that was placed in there. So you can see even down here, this is the solder line coming in, and then the flame torch that you'd use to wick that solder in between the pieces. What's up?
When, for brazing, are you talking about connecting 2 pieces of aluminum, or are you talking about like aluminum as the connection with metal?
Gotcha. So
like I'm familiar with brazing steel and the brazing rod would be bronze.
gotcha. Okay, so let me repeat the question. And so the question was, for brazing, am I talking about aluminum being bonded or aluminum being the brazing rod? And in my situation, I was talking about an aluminum brazing rod to bond aluminum to aluminum. It's something that I have done once, marginally successfully. I'm not a pro at brazing, but it is a process that I wanted to make sure that I listed as an available option. And Ada, I'm sure that your jewelry work has you far more experienced.
I've never done anything with jewelry, but with like sculpture stuff.
Yeah, and Jeffrey, who's one of the facilitators, he made a large aluminum frame, and if you were in here a couple of weeks ago, there was a day where he was walking through with a 8-foot tall frame that he had brazed together with aluminum. So instead of MIG welding steel, he was using a MIG torch, a specialized MIG torch, to braze aluminum pieces together. So using aluminum to bond 2 other pieces of aluminum together, which can be a really nice process.
You can do that with steel. I mean, not with aluminum, brazing rod, but with making
Yeah.
usually
If you have a longer question, you should come up and say it to the mic, just in general. But yeah, that you can use aluminum to connect other materials also, that you can use aluminum to connect steel.
Yeah.
That's there's tons of options, and if you would like.
For our purposes, though, it'll be plenty strong. Like you wouldn't braze if you're building a bridge.
Gotcha. So you can braze steel together. To just try and report what you're saying for the people who are listening. You can braze steel together with aluminum if you've got an aluminum brazing rod, but it's not as strong as a steel weld. But for lots of our things that aren't architectural, they're not bridges, they're maybe not even a table that you'd sit on, but might have a piece of art in front of you, it would be a perfectly adequate way to get things together. And that can be done with a regular old torch like you'd have that you'd buy at Home Depot, rather than needing full welding equipment. You also wouldn't need the same like eye protection. You need to protect your eyes, but you wouldn't need the same amount of welding goggles and all of that, right? So it's a little bit more approachable way to connect pieces of metal if you're brazing with aluminum. But when I was talking about this and putting it on the slide, I was thinking aluminum to aluminum with an aluminum brazing rod, which is dicey. It gets mushy fast. It didn't work super well, but I was able to make a connection when I did that now years ago. It was actually part of the Ghostbusters pack. I had brazed some aluminum pieces together for that. So those are all options. I think that welding is actually a great one to try if you're looking for a fun new field to go in to try out for the next 2 weeks. Getting on welding and just doing some steel welding with a MIG welder is a great place to get started. It's lots of fun, and you can just make a MIG weld that doesn't have much purpose, but maybe spells out your name. It can be a fun way to learn a new skill and get started with that. But it is a great way to put together architectural sorts of pieces of metal. So you can definitely build structures with a weld. That's a great way to join metals together. And so that works really well for steel and making those steel to steel connections. So then the next part is, what do we want to do? There's several machines in the metal shop that really are about being a machinist. And so this is a bit of a mouthful, but a machinist is a person who uses metalworking tools and understands them at a professional level, far beyond what I do. But they understand a little bit of metallurgy, a little bit of how to use those tools, and it's a trade. A tradesperson or trained professional who operates those machine tools and has knowledge of tooling and materials to require and set up machine tools, including milling machines, grinders, lathes, and drilling machines. In Cleveland, this was often a common career path for many of our kids, that they knew that they could get a job as a machinist. It's a good living. You can really enjoy what you're doing. I had several friends who would be machinists for the airline and military, and so they were building things to very tight specifications, very high quality machining, and it's a great paying job. So this is an entire category of careers where you can be a machinist and you can become a specialist on one of the machines if you really want to, or you can master several of them and be able to produce in a larger scale. And several of our facilitators, at least Jeremy has experience in a machine shop, and I think several of them do. They've got that background, which is neat to ask them questions, poke their brain, and get some resources from them just to understand all these things a little bit better. And so the metal tools that a machinist would focus on in the shop are going to be a little bit bigger and a little bit higher power. So you've got the metal lathe, which is the king of all machining tools. That's the green one here. We have a larger one that Lior just rebuilt today, a 14-inch metal lathe. And so there's lots of options for that. But the lathe has been around since ancient times. Not the metal lathe, but the lathe in general, where you just get a piece of work to spin, you have a lathe. But these metal motorized ones came about in the 1700s. There's some really fascinating videos I'll share about the history of the lathe. But from the first good lathe, all of these other machines have been built and born. So it's an interesting dynamic to think about them coming all out of the lathe. The Bridgeport Mill is this big guy. There's a training coming up on Sunday. Those trainings do have a cost, but they are a whole day thing, and you can learn how to use one of these milling machines from blank. And milling is where you take a spinning end mill, sort of like you might have seen on the CNC or Shipoko, and you just move it through metal. So in the Bridgeport, you're manually doing that. You're manually moving around the spinning end mill, and the spinning tool is there and available. Just like in the lathe, the work is spinning there in front of you. So they both have some element of danger that needs to be taken into account. You need to learn how to use these tools safely. They're definitely on an interlock. You can't just walk up and turn them on because you need to take certain things into consideration. But then beyond that, a machinist
Corey?
Oh, yeah.
There's a question in the chat. What metals would you use or not use on the metal lathe?
Oh. On the metal lathe, you can use lots of different metals. The one that I used in the class yesterday was a cold rolled steel. But the instructor, Chris, was talking about the special considerations you'd need to use if you were talking about titanium. But you could also machine other softer metals as well. Titanium, he said, was springy, and you have to be more aggressive with the cuts because it's springy. With aluminum, you're going to need to take out bigger chunks at a time. With steel, you can sort of nurse off little pieces to really tune in to where you want to go. And hardened steel is going to be too hard unless you have a specialized carbide cutting tool. So the lathe can really cut most anything. Brass would be a good one to cut on there. But you just need to look up and do some reference background on those tools. It's part of the machinist is knowing all of those things. But if you're gonna cut a new metal that you haven't been trained on, I would definitely say you need to do some research to figure out what speed does it need to spin at, how aggressively do I need to push through the metal, like how many inches per minute does my cutting tool need to go across the surface. All of those things you'd need to look up per material. But
Corey?
Yes?
When would you use cutting oil?
Cutting oil is gonna be useful if you're trying to cool off anything. And in several of these, you're gonna use a cutting oil to try and remove heat. Some of them, you need to look, that's another one of the things that's different per material, which is one of the bummers of the metal shop. One of the things with steel is that if the chips come off blue, you're removing all of your heat with those chips. And I saved some blue chips from the metal lathe class that I took so you could see it, but it really turns blue like this blue here. So this blue color, sometimes the material itself, the chips will remove heat, but with a drill press especially, you're gonna wanna have some cutting oil to lubricate where the cut's gonna happen. With the Bridgeport, you're gonna wanna have cutting oil. With the standing bandsaw, you don't very often need a cutting oil, but with the horizontal bandsaw, it's built into the bandsaw. So some of those it's taken care of for you, and others it has to be manually added, but you do sort of, it is on you, the person running the tool, to look it up a little bit. And I'll come up with some guidelines, but on the metal lathe, we were not using cutting oil yesterday, except for when cutting a groove like into the side of the material. If you're removing surface chips, it was considered different than if you're cutting like deep into the material. So it is also a little bit contextually based, and those are all things that I would want to look up before I'm making very aggressive cuts. If you're using the metal brake or you're using shears, you're going to be fine without any cutting oil. But if you get to the drill press, I would definitely take it into consideration. And on the bandsaw, you may want to think about if you want to, just a quick Google, do I need cutting oil for this material on a metal bandsaw? And you should be able to get what you're looking at for your particular material that you're working with. So it's not something where I can say like this is the always statement. And if I were more of a machinist, I would have more useful, this is the common rule that I've learned over years. But some of this metalworking stuff is still an area where I'm growing a little bit into also. So it's definitely something where you can make some really great things, but you need to proceed with enough caution and respect, for these tools have some aggressive strength. And if you don't use cutting oil, the worst that's going to happen is that you ruin that drill bit, right? Typically the outcome will be that you get your tool will become very dull very fast. So if you use tools on a mill, and so on a Bridgeport or a CNC, so we have a sharpener for those, so that if you're making cuts and your tool does get dull, you have a way to resharpen that. And so there's a whole sharpener that we have in the machine shop that you can use if you want to sharpen one of those things. Then there's also a whole suite of measuring tools. The thing that I have pictured down here is a surface plate, which is, it may just look like a table, but it's a perfectly flat table to a measured extent. And flatness is actually relatively hard to have. So this is, I think it's from an old Air Force base, our particular one. And so measuring flatness or measuring from a flat surface is a really important thing for a machinist. Up here is a comparator, an optical comparator. So if you wanted to visually inspect the things that you've cut, because you need to build them to a certain specification, you can use a comparator like that to visually inspect, are my threads the right pitch? Are they far enough apart? Are they close enough together? All of those things can be really tricky. And it's important when you're doing this to think about what are the pieces that you want to go after? Like, what are the things that you want to build? And we're going to get to example projects in just a minute. But because the detail that goes into metalworking and the sort of research that it takes to get to the end point, there's some safe, easy to do ones where you're cutting off shapes and then you're welding them together. That's a fairly quick skill to acquire. But if you want to really fine-tune control of a cut, that's going to take more effort than you think it might. And so choosing a starting machinist project, the projects that you do as an early machinist are often far simpler than you think they would be, right? In the metal lathe class, we turned a step-down cylinder. So we turned it to a certain specified diameter and length, and then that was the day-long class, was learning how to do that. You may have a goal or an idea of what you want to make out of metal, but depending on the particular set of materials and how you're going to need to process them, you may want to think about, is this the right scope for the week? And so don't pick something that's too big and out of range. But
Corey, we've lost your sound.
oh no.
Sorry, I'm working on it.
Oh, JR's working on it.
Just trying to get the video back. Yep.
Can you? Oh, hold on. I can unmute.
She's got it now.
Okay,
You can
cool.
hear it again.
Okay, good.
It was just I'm just crashing and restarting.
Gotcha. JR's working through the world. Okay. So metals are, there's a lot on here that you'll want to deburr them, and they are different from other materials like ionic bonds in salts and crystals, or covalent bonds in diamonds have a lot of strength in a tetrahedral shape. Metallic bonds let electrons pass freely, and that's what makes them so conductive. And so a part of the nature of a metal is that it lets electrons move around, but they're very close together. You get lots of burrs because there aren't fibers like you see in wood, or when you get a cut, it can be a very clean cut. A burr is always going to be on the edge of a metal cut. So you'll want to take that into account. Even if it's a very tiny burr, you'll probably want to grind it off at the end of the processing. So let's talk about personal safety. It's an important part of working in a metal shop. You'll want to make a few choices that can really make your time a lot more pleasant. You're going to want to choose non-synthetic clothes. You'll want to avoid hanging sleeves, tie back hair if you've got lots of hair, impact resistant goggles. So those are the goggles that are in the drawer right in front, or Z87s, or what we'd always tell our Science Olympiad kids were chemical and impact resistant goggles, Z87 plus. So if you have your own goggles, you could wear those, but otherwise use the impact goggles for our space. And then do not wear gloves, which is a little odd, unless you're welding. Gloves seem like a good idea at first, but the problem is that you'll misjudge the distance of the glove to the workpiece because it's not your own finger. You're used to your fingers all the time, and if you get a glove and it gets pulled on, now it's pulling on every surface of your hand, and it can quickly turn into a bad situation. We all saw that Jimmy Fallon for a long time had his finger wrapped up. It's a terrible thing that's called being degloved, where the skin gets pulled off the finger. It's not pleasant. I think his was from a ring that got caught on something. But you don't want to wear gloves in the metal shop for that reason. It's an unpleasant thing to even think about, so please keep that in mind. When you're welding, you need gloves so that you're electrically isolated and protected from the heat. But for all of our cold cutting things, it may seem odd, but you don't want to wear gloves during that process. So you got to take that into account. Also, you want to clamp down your workpieces so they don't move on you. Even what may feel like a slight movement can turn into a lot of movement very quickly, so you want to make sure that things are clamped down. And before you turn on the machine, know where the shutoff is and know how and why, how you can get it to shut off. If there's an emergency brake, if there's a big push shutoff button, all of those things you should know where they are prior to even turning it on. And it's probably the same spot, but it's good to know, just to like double check for sanity's sake. You don't want to get caught with a machine running and like, how do I turn this off? Because you may be stressed when asking that question. And then a buddy system for several of the tools is essential. There are several things in there that are marked buddy tools, which means you need another person in the room. So that if you need something, you can yell and someone can be there to back you up, that there's another person to see what's going on in case you pass out, in case, whatever could happen. There's another person there just to be accountable for, hey, I know that they're aware and doing well. Even if they're not an expert, just somebody in the room. So, getting to slightly more palatable things, precision measurement. Measuring is actually pretty hard, is the case I'm going to make here. Measuring is fairly hard to do. It's something that if you're in the metal shop, you may start to measure things. And we're going to think about measuring more and more as we get into designing. And we've been sort of freewheeling it on the design side of this train. But in order to make a measurement, think of all the different pieces that have to come together. In college, for my physics studies, I actually had a class on measuring, which is kind of crazy. And so you'd think about all of the different pieces you need to have. You need to have a measuring system that you can agree on. In French Revolution France, there were 215 length measurements. 215 different systems of measuring length, which is insane. And that's probably even a small number for misestimating the amount there were. So we all now have the metric system, or the American system, which, fun side note, is based on the metric system. America just doesn't tell you that. But the inch is officially 2.54 centimeters. That's its definition. And so you have a measurement system that you can use, a tool that's calibrated to that measurement system. You need to know how it zeros. Like in the case of a tape measure, this thing on the end slides because the thickness of that end piece matters. So it pushes in if you're measuring up against it, and then if you're pulling from that end slider, it needs to slide out. So the thickness of that little metal tab is taken into account for the zero on the tape measure. So knowing where your measuring tool starts may be a sneaky part of how it works. Most people don't know that that's why it slides back and forth on the tape measure. But it's a fascinating piece just to know that that's how it zeros. And then if you're measuring something, knowing where both ends are at the same time, which may seem like a silly part to have added, but if it's moving, that's very important. Or if you've got something that's round and you want to make sure that you're getting a diameter, knowing that you're lined up to that exact diameter can be really important. And then you need to actually do the comparison between the measuring tool and the thing you want to measure, and then identify what uncertainty you have. How much do you know that the length is 3 inches if you measure it with a ruler versus a micrometer or all those different measuring tools? So in the metal shop, I would invite you to try calipers or micrometers. There's a few people have different words they use for these also, but calipers are the name I'm going to go with. They have 3 good forms of measurement. You can do pinching between these teeth, and then sort of these teeth on the other end, they spread out to fill a gap. And then there's the depth measurement over on this side. This is a dial caliper. It's got a big dial in the middle, and so understanding how to use those, I'll push out a video over the next tonight so that you can see how to use a dial caliper. There's also digital calipers, and then there's sliding calipers. Each of them is slightly more or less accurate, but they're measuring in the 10,000ths of an inch very often. And so you get really nice measurements. They're usually limited to about a 6-inch throw, so you can't go with something very large, but you can know the length of something really well if it's under 6 inches. So that sort of sets a scale for if you wanted to try and build yourself a scoped dimensional project, it gives you a reference point. But just playing around with one of these, I marked in blue arrows all of the parts that move. All of the ones that don't move aren't marked with an arrow. So the actual body and this upper tooth and that tooth, those stay fixed. The other ones slide together as one unit so that any one of the 3 could be used to measure at the same time, all off the same gauge. They're a pretty ingenious little tool, and I would solidly recommend, if you don't have it, I have one at home that is just personally mine, and it's great. I'm very glad that I have a nice one. So, some starter project ideas. A good thing to consider when thinking about a metalworking project especially, of the different areas, this is one category of MakeHaven where I've seen people really do a lot of dog fooding, which is building things that you're going to use, using the shop to make the shop better, right? If you're trying to build something where you want to make a quick comparison, or an example that I have linked in for Adam Savage is to make your own die, tap and die straightener, a thing to hold your tap and die straight up and down, to build a tool for yourself that you would be able to use in the shop. Dog fooding is often that. Or a good example is Google built Google Meets so that they could have discussions across their different locations. They didn't build it for all of us to use in the midst of a pandemic. They built it so that they could have people in Boulder talk to people in San Mateo. They built it for that reason, and then the rest of us get to use it after they did some dog fooding. And so there's actually an entire Wikipedia page on dog fooding, or eating your own dog food, using the things that you make. But some good starter projects. Things I would recommend, although you might have something else in mind that you should totally go after. Just getting your first weld in would be a good project for the week, just to get in there, make it happen, put a few pieces of metal together. And if you have a broader plan, that's great. If you just want to get good at welding, it's an entire career to be a welder. You can make 90 grand just welding things together. So just starting to get relatively good at it over the course of the week could be a useful project in and of itself. Sheet metal cutting and bending, using a file to shape soft materials into like very ornate shapes could be really cool. If you're really trying to master that fine-tuned thing, think whittling, but in metal, to use a file. to make a knife like from a blank starting point would be a really interesting project. It's fairly complicated and would take a lot of research, might take up the whole 2 weeks to build a knife. Cutting and shaping the ends of a threaded rod. If you're brand new to metalworking and you're a little timid, that's a great place to start. Just get some threaded rod and some nuts that match, and then make the cuts and then shape the ends on a grinding tool. And you're gonna learn a lot of things through that process. How to deal with the chips, the sparks that come off at you, how to not jump away. There's a lot of pieces that can come from just sort of what feels like a basic project. Cleaning and polishing is really a good tool a good process to get started with. And then spot welding or riveting a metal box out of sheet metal is another good one to go after, because you'd need to make your cuts, think about how you shape the geometry, deburr the edges so that it doesn't cut you when you're handling it, and then putting in rivets or spot welds can be a good way to hold a box like that together, just to hold pens on a desktop, right? Not anything seemingly fancy, but it practices a lot of the skills for what's going on inside the metal shop. Those could all be reasonably scoped projects for what's going on. Yeah?
How can we make an aluminum box if we can't use aluminum with spot welding?
So I would say a rivet would be a great way to go. The rivet, oh, the question was, how do you make an aluminum box if you can't use aluminum on the spot welder? And so you'd want to take a look at the details exactly, because I think you might be able to spot weld aluminum, I'm not sure. But you can definitely rivet the aluminum sheet together. So if you buy an aluminum sheet of reasonable thickness, you line it up, you drill a hole, and then a rivet to hold it together. You can get a nice riveted together box. But Ada, it looked like you were...
You can weld aluminum to aluminum. You can't weld aluminum to like almost any other metal that we've been talking about, because it has a lower melting temperature. So like...
Yep, yeah. Come on up and tell us that. You've got a lot of info to share.
You can weld aluminum to aluminum. You just can't weld aluminum to like steel or even to things like copper, really, because it has a much lower melting temperature. I think its melting point is maybe around 1100 degrees Fahrenheit. And like copper, silver, gold, those are, depending on the properties, they're all going to be in like the 1400 range, and steel is going to be like over 2000. And in order to weld, you have to melt both pieces of metal that you're attaching. That's like the definition of a weld, and flow them together. And so the aluminum would just be completely liquid before you even like melted the edge of the steel. So you can weld aluminum to aluminum. It's just much lower temperature, so you're using slightly different tools.
And would you use a MIG for that?
So I know less about attaching aluminum to itself because I don't really work in aluminum. My understanding is that you would use like a particular setting of the MIG. You'd have to kind of like
I know.
yeah.
So Jeffrey was clear to me that there's a special MIG end, a MIG gun for welding aluminum, and he said probably if it's on there it was me and I forgot to put it away, because he said it's a specialized tool just to do that with aluminum to aluminum welds. So you can, but you got to keep it in mind that it's going to be different and it's way lower temperatures. So when Ada brought up a great point. When you're thinking about metals being welded, it is melting them together. And so it's an analogy because it's not perfect, but think about trying to connect two ice cubes if you're sitting in a freezer, right? You could breathe hot air onto them so that the edges become wet and watery, where the edges are locally melted into water. Then you press them together where they're wet and watery, and then they'll refreeze back together, right? So in very much the same way, you're doing that, except you're spitting hot metal on it to melt it. So it's not exactly that, but it's similar. And there's various versions that work. You want to say more?
Sure.
Go for it.
This is not exactly
Yeah, it's
the
not
same,
exactly
but basically what I was going to say is, whereas welding is you have to melt both pieces of metal. Like brazing, soldering, sweating, those are all extremely similar and essentially the same process, but like at different temperatures. And soldering, there's like a huge range of temperatures. So like the electrical soldering that we were doing is fairly low temperature soldering, whereas you would like with making jewelry or something like that, which is in particular what I know about, you would sometimes you would weld. You know, you can weld any metal to itself because both pieces will have the same melting point or very close. But attaching different metals, you often have to do things like brazing, soldering, sweating, because what you're using this like third party, you're using this third thing, which is either the like brazing rod or the solder, and the two work pieces of metal are not going to melt. You're often operating like just under their melting point, but and Corey, you probably know more about this. It's like brazing and soldering and stuff are much more like a chemical reaction, right? Than welding, which is sort of like they physically flow together. Yeah. Whereas with brazing and soldering and stuff, the slightly lower temperature, the lower melting point metal that you're using to attach your two work pieces, it like kind of bonds with the two. Or you can probably explain that.
So for soldering and brazing and sweating, all of those things, I think a good example would be to come back to here and talk about the different categories of bonds. And your metallic bonds are going to stay within the solid pieces that don't fully melt. But you're going to imagine the surface of any metal. It won't be perfectly smooth, even though this is a perfect, 4x3 grid. Any surface of a metal won't be perfectly smooth. You're going to have places where in the case of copper being soldered with tin will sort of wick its way in to those gaps where there's just a little bit of copper missing, and it'll fill in all those voids. So instead of really fully integrating, it will fill the whole surface between and bring in a metallic bond from surface to surface. And then you'll also, if there's any gaps, you'll get van der Waals forces that really bring the atoms closer together. You can have sort of a temporary bond, but the strongest is going to be weld, where everything's melted all into one piece. But having a full surface-to-surface contact is certainly enough that we can, we use it for pressurized plumbing, right? That is often a very strong bond, but welding is a stronger bond. It would be for structural pieces, whereas you wouldn't want to sweat or solder for a bridge, right? Like those pieces would need to have the stronger bond of actually fusing the metals together. So there's tons of stuff to get into there, and then there will be people that will talk about all those things for a long, long time. There's tons to know. And its whole, when we go through that definition of a machinist, it really takes in all of those pieces and all of that knowledge base to make that happen. And as we're dipping our toes into the metal shop, it's good to get started with that work and start to wrap our minds around it. But you can definitely go way deeper and become an expert in those areas. But it will take a lot more knowledge than you might initially expect. So here's our next week things. But what I want to do is make sure that we have some time to talk about. So next week we're going to cover tempering, lathe and milling basics, a CNC conceptual overview. We'll talk about water jet cutting, electroplating, and then more about the welding, brazing dynamic. We're going to go into that more next week for like the exact how. And you may not need to know how it works to just say, hey, I want to get a badge in MIG welding and then do some welds. But to get the theory behind it and the difference between those that we just got a preview of is definitely a good thing. So we can talk about that more next week just to make better sense of it all. So there's a lot more to learn. But what I want to do is make sure that we get a chance to talk about what happened this week. Oh boy, I don't want that. To consider our coin cell battery holders and LED sequins, and then the circuits that go along with them. So we've got these different things to try and talk about what happened this week. If we can see any example projects, it would be great for show and tell, to sort of troubleshoot our way through them, to try and answer any questions that we have at this point would be also really great. And so let's start off with, does anyone have a preloaded question that they want to ask to make sure that we get to address any of those that come up to talk about what's going on? And we'll see if anybody unmutes, because now I can see who's on the chat. And then if you've got, you okay?
Could you give an example of what you mean by that?
A
preloaded question?
Oh, like you really wanted to know, okay, I got it wired up and I think I understand what the switches want. Like maybe your circuit is not working and you don't know why. And you want to just like pull up an image and we can troubleshoot. Or if you had it working and then it stopped and you're curious as to why that happened. That's what I mean by preloaded question.
Gotcha.
Yeah.
I might have one, but I think I know why, but I think it's worth talking.
All right, well, you want to come up and ask? We've got one in the room, but then we've got some others that we can talk about too.
So, I couldn't find my disgusting bunny tool belt, which I was going to add a sequin to the eye. So I made this like little pride thing with the sequins. I bought some conductive thread, and what I found is when I turn the switch off, it kind of blinks and stays on. So what I think happened is that when I knotted the conductive thread in, that the knot is probably also touching the on part, and so it's probably hitting it like just a piece of the thread or something.
So when you is it spot? So my question is it spotty when you turn it off? Like if you were to turn it off, does it sort of blink on sometimes?
Yeah, like this.
Yeah.
See?
So can you see in the video, people like Jamie is touching it and it's blinking, and I think you're totally right. Like you've got some contact between the switch and the on. So somewhere what you've got is a short circuit that's working in favor of it being on.
Yeah.
It's not like removing power from the, sometimes a short circuit is the easiest path for current to flow. But I think you're totally right. You've got a connection that is tied in to, and people might be able to see on screen, you're short circuiting it right here, like before the switch even happens. And now I'm scrolling way out of.
Yeah, I wonder if I could. Yeah, it's just, I see the knot like right here. It's hitting, see, like right here. You can actually see it.
Oh yeah.
It's most likely when it's turned around and touching, like sandwiched between the fabric of my coat and the circuit. It's most likely just hitting it like this.
Yep.
Which actually is exactly what I'm doing right now with my finger.
Gotcha.
So
you can see that like what you've got going on is this extra green wire is coming off the middle, and so and man, my mouse is freaking out. But you've got like this extra contact that's accidentally there, and that's what's making it blink. The blink is a really cool effect.
Yeah.
But you want to be able to have it be off when you want it to be off.
Exactly.
And so it's like part of the reason why we chose this project is so that we can have exactly those sorts of discussions.
Yeah.
Just to see what's going on. So that's cool.
And another thing that I found is that I sewed everything on with the conductive thread. The only thing I used regular black thread for was to, fix the circuit board to the back of the jacket. If I were to do it again, I would sew everything on in the way I want with the black regular thread, and then take the conductive thread and do very clean straight lines to the circuit, so that not only don't I waste the expensive conductive thread, but things like this just won't happen, because I could even glue it. I wouldn't even need to sew it. But yeah, I think that would be just another way of doing it very clean and precise, and have a little bit more control of this.
Cool. Thank you for sharing. And a good workaround for you is to also, like, you can take the battery out, right? If you need to If you need to turn it off, you can take the battery out. And if you're ever gonna, a switch is a great thing. You always want to have a switch and an ability to make a switch work. Anybody else have a question? Kate?
I don't have a question, but if we're gonna, I finally got mine to work, and it kind of fits in well after Jamie's presentation. If you want to.
Yeah, let's see it. We'll JR is gonna hop over, and
It's on the site for doing that, or I can share screen it. It's better to me.
JR is working on it. So you can share your screen.
Okay. I will. I can pull up my own website here. Should be able to do that. All right. Okay, hopefully you're seeing this now.
Yep, we are.
Seeing my webpage, hooray. So you can kind of see a little bit in my gallery here, but I'll go down to the actual post about it. Oh, is it going to be slow? Whoops, I clicked on the wrong one. Sorry about that.
You're all right.
Or did I link it to the wrong one? See if we can get there. There we go. So I made a, I'm calling it RT, which is my t-shirt that indicates whether I am feeling extroverted or introverted. And so it's basically iron-on vinyl, heat transfer vinyl. This was all my trying to figure out circuit. That was an interesting experiment. This, if you can see this, Jamie, this is me hating conductive thread.
Yeah.
I had some really rough experience. And I can relate definitely to the, I assumed it was my poor knot tying or whatever, but it just didn't have the stability, and it would blink and it would go out, and then I would be like, is it the battery, is it the light, or is it my circuit? Then I switched to actual wire and really didn't have any problems anymore. So I think that in this case, that's what worked better. So I made this circuit that I actually put onto a panel into the back of the shirt, and then I kind of, it's hard to see here a little bit, I zigzag to cure it. I don't know if this will play for you, but hopefully you can see that I can, there's a switch down here, and so I can switch back and forth. And so basically I can have it light up with the green light or with the red light with the switch. So
that's actually brilliant, and I love, very nice.
You should sell those.
Yeah. The comment was you should sell those. Yeah, so I think that one of the things that's frustrating about conductive thread is just that it's conductive everywhere. And so short circuiting with it is very easy to do. It's one of the major struggles. It can look really nice if you're already good at perfectly hand embroidering things, but it also can be really frustrating. So switching over to wires makes total sense. And I'm glad that it worked. So, and then how was your switch mechanism? Did you use snaps, Kate?
Oh yeah, I guess you couldn't really see that. I should add that in. But yeah, they are, it's just like a snap like you'd have on the bottom of a onesie. And it has the two bottoms, and then I have the live wire that goes into either the red one or the green one to complete that circuit. So you can just switch it back and forth. And of course, since the snaps are very conductive, if you actually just touch them, it'll light up. But if you want to keep it illuminated, you can snap it in. Which was Corey's question, and was a real simple switch to make, so that was cool.
Yeah, switches people often will think are like a deep earth mystery, but they're usually much simpler than you're thinking about. It's just, can you make contact or can you not? Can you break contact? And if you can do it in a controlled way, I would call it a switch. So there's lots of opportunity for those to look lots of different ways. Cool. Aaron, you're unmuted. You want to go next?
Sure. Actually, I had a quick question, if I might.
Yeah, absolutely.
So it seems like there's a shared loathing of conductive thread. I haven't gotten there yet, But what I'm wondering is like maybe are there certain knots that work better than others? I wondered if anyone who might have some experience might be able to make a suggestion, or should I too avoid conductive thread and go to wires? Or am I missing something?
Jamie's saying that they thought it was fun and it's worth doing, and I think that it is worth doing, especially if you want to go deep into the hand embroidery world. The knots, I would just say make as tight as you possibly can so that they don't have any extra. And then you can also sort of isolate them with nail polish, can work well to cover up the edges so that they don't move around. Those are some good tips.
Sort of like, it would be like insulation.
Yeah, it's just insulation. The nail polish is insulation that you're adding on after the fact, once you've got the connection that you want. But it totally can be frustrating. So.
Awesome, thank you.
Yeah.
Should I share my screen to share my side?
Yeah,
or?
you're up there. You're ready to. If you want to share, you totally can.
Okay.
Yeah, the like. It's not with any intent for torture, because some people love conductive thread. I'm pretty medium on it, but it's good to have this experience so that you can really love wires when we get there. Sorry, that's just a touch of evil. I'm a high school teacher. It's got to be there, right? It's buried deep inside, but it comes out sometimes.
Bear with me one second.
Yeah, you're all good.
Can everyone see my screen?
Yep.
So this was sort of a weird week for me, a weird couple of weeks. I had this hat that I got in Ann Arbor, and I'm not a football fan, so I was like, I want to cover up the University of Michigan logo with something near and dear to my heart, which is my favorite bad guy from a TV show called Thundercats, way back in the day. So obviously this isn't cleaned up. I did clean it up after the fact, but I wanted to just practice some simple stitching, like lots of repetition of the same thing is good for me. It helps me feel confident and comfortable making something. And also just after seeing Corey's EL wire experiment, actually not experiment, just like gorgeous, cool thing. I was like, I want to do something similar. And I was like, the goal of this hat would maybe be to meet someone else who likes this cartoon as much as I do. So I was like, I'll wear this, keep my head warm, and maybe have a fun conversation at some point. So pretty straightforward, but I wanted to just sort of get savvy and get exposed to a couple of tools that I haven't really used before. If I can call crocheting needles tools, I've never used them before, and the knit stitch of the hat made it really easy to do this. I wanted to get some nice embroidery cloth and take a stab at that. But there is something that I noticed that was like a mistake. I assumed that the EL wire would play really nicely on the edge of the hat, and then I put it on my large head and noticed that it didn't actually fit. So I had to adjust it a little bit, and I think if I could do it again, I would actually put the EL wire not on the edge of the top of the hat and the bottom, but rather like on the flat. So that way it would be able to actually expand with my head rather than like being positioned at the top in a way that might not be visible, because if I put this on my head, sometimes the wire will actually hide behind the lip. So I hope that makes sense. I can put it on my head and show you, but I think that I'm going to do it again and move it.
No, you're. I totally wouldn't have thought about that, but you're right. Like what I'm thinking about now is my conversation with Megan about the sewing machine and how a straight line stitch is good for fabrics that don't flex, but the hat has to flex to fit on your head. So now I'm imagining like, what if you did a zigzag up and down those like ribs around the rim, so that any stretch you want to get, it would just sort of make them slightly diagonal. right? So if it's straight up and down in between those like ridge pieces on the picture, like you could sew them in there. You have your clear or red stitching to sew them in, and then if it needs to expand, it just cambers them out a little bit so that you've got triangles instead of parallel lines.
I really like that idea.
Yeah. And it should hide nicely. You might even be able to weave in and out of the hat, like poke it through the knits, so that the corners, like the loop between each vertical stripe is pretty hidden. And that could really, that could really look good, actually.
I'm gonna do that. Here, I'll put it on real quick just so people can see the mistake that I made, because it's kind of apparent here.
But yeah, I'm just thinking about like the tension in that wire, because it doesn't have.
It's also look interesting to, since it's orange, to just go in a circle.
Yeah, to contrast it.
It's extremely tight. I don't know, and that's kind of uncomfortable. And then the wire like kind of moves in an awkward manner. And you'll notice that like it actually ends up hiding behind the actual lip of the hat. So
yeah,
I think again, just to reiterate, doing it on the flat right here rather than on the edges is the way to go.
Yeah, totally. And that's like a nice project you could do while watching a movie, right? Like stitching while the movie's going on. That feels like you're
Abbey. That's what I've been doing.
There you go. Yeah. All right. Anybody else want to share a thing that they made in person? Or Ada, you want to come up? Yeah. It is a good combo.
Yeah. So I just augmented a jacket that I had with a patch on the back with one LED. In hindsight, I wish I had made the switch more accessible. It's kind of hard. Oh. Where? Oh, yeah. But.
Trying to find it. We're good there.
So, obviously that stuff. The switch is not super accessible, and so if I was like, not necessarily if I was doing it again, because I don't have another jacket of this like this, but I just need to figure out some way of augmenting it so that the switch is more accessible, or creating another switch mechanism.
Cool. You all good?
I am good.
Cool. Good. All right. Neat. And then let's see. Anybody else have an example of a working or not working thing? Because not working is often, even though it may initially feel like a thing, I think, well, as a teacher, we too often tell students that a failure is bad. It's a permanent state, is I think what kids end up thinking in high school. Whereas as an adult, I have failed at many, many things all the time. I feel like I fail more than I succeed. And so if you have a failed thing that you want to talk about, I'm game, and I want to help make sure that we move forward, because that's part of the ethos of this entire class, is that you learn from an experience that you had and move it forward. So there's a couple people that haven't shared yet that I'd like, if you've got anything, it'd be great to hear sort of what's going on, what's happening, and then try and make that connection. But Jamie, you also raised your, you want to?
I'll let other people, I can ask you after class.
Okay. Sure. Lila, Ruby. Kate's unmuted. You got something?
Hey.
Hey. Yeah, we can.
My screen is frozen.
Hello? Oh, you're not frozen on our side. We can see you.
Okay. Yeah, I can hear you. Okay, everything's frozen, but I'm going to try so that you can see me.
Yep, we can.
I made this coin purse, and I was making a mask, but I ended up running out of time. So I ended up making a coin purse with a zipper, which I'm super impressed by because I had no idea how to do that. And so I hand sewed as well as used the machine. And I still want to make a mask and have some LED lights on the mask, but I also remembered a big problem that I have for whatever reason is like I never have enough light when I'm looking inside of like my purse or my book bag. So I wanted something portable, and I was gonna make a little pocket inside so that I could like keep other stuff in that pocket too, because I have too much crap in my bag all the time. But anyways, I guess I can present and show you my circuit. I initially didn't sew it on because I wanna eventually move that circuit to the mask. So, but I think now in hindsight that was a bad idea, and I should have just bought another circuit. So I'm going to try to present.
Cool. I actually really liked Kate's idea of putting it on a backing that you could move around if you wanted to.
On a backing. Yeah. So like.
But I think that you're presenting. We got you.
Okay. So I just had it loose. I did clip these ends and I did tighten everything, but I think this is too loose for it to actually like turn on. I think that was my issue there.
I wonder, would like the last one turn on, but not the middle ones? Did you ever see that happen?
None of them would. I feel like when I first did it, like the first one kind of like flickered, but I mean nothing. I wonder if I should have just like double knotted each one, you know, or just had it tighter. Do you know what I'm saying?
Yeah, I do. I think that with conductive thread, it's often about the contact that you've got. So tying the knot so that you've got good contact is tricky. But it looks like, just from looking at what you've got there, it looks like your circuit is wired correctly. It's just got contact issues. So I think that it seems like you're on the right track totally, but tying it down more aggressively, like Jamie had said, making sure that it's really attached to the piece, and then using the conductive thread to make a really tight loop so that you've got contact might make the most sense. Or if you want to have a semi-rigid thing that you can move around in your mask or on your purse, it may make sense to just use wire also.
I also noticed that, like, while
I would.
Oh.
Uh-huh.
She can't hear you.
She can't hear you. Come on up.
I also noticed that when I was, you know, sewing these together, another reason why I would do the black thread first and then a clean line for the circuits is because I also short circuited in that, like, the wires would touch for each of these, which would then just shut it down completely and it wouldn't work. So I had to like cut some off and start over again, and then do it so that each wire to each sequin was not touching any other sequin or wire or anything. Like, it all had to be cleaner, and so that's why I would do it that way again, just to make sure that there were no wires crossing, like the Ghostbusters say, don't cross the wires. Yeah.
Don't cross the streams. It's an important life lesson.
Yeah, I would say that I had a very similar experience of like, it's working, wait, it's flickering, wait, is everything good? Did I do it wrong? And I wonder, I ended up doing that back panel when everyone was talking about washing it, and I was just like, if I just can take the whole thing off and throw the shirt in the wash, that might be easier. But I also found that maybe even just as a beginner, that having like a panel where I could keep things real organized, like Jamie was saying, seemed to help. And I also wonder, even with the conductive thread, if you have something where you can, because it is so thin and so floppy, I don't know, Corey would probably know more about that, but it felt a little difficult for me.
Yeah, I think anything you can do to give yourself some rigidity with the conductive thread is really helpful. It's definitely a floppy material. Like, it feels like a springy thread for sure as a material to play with. So having a backing or something that you can get any stability you can is really helpful. So if you can do it all on like a sewing wheel or one of those tension loops, can really be helpful, just because you've eliminated as many variables as possible. So I would totally recommend that.
This makes so much more sense. Thank you.
Yeah. All right. Next up. Lila, do you want to share? Yeah?
Hi. Is
Hi.
it? I can't tell if I'm on. I think it's just the way my computer's set up. Let me make it so I am.
You're totally on. So we can see you, we can hear you. If you want to present, we can even swap it around so the presentation is big.
Yeah, do that. I'm gonna present.
Okay, cool. JR, are you on it? Cool.
How do I do this?
By we, I meant JR can do that. I don't want to take any credit. JR is the master that makes this show run.
Except it crashed twice.
No. We fix that in post. Now we're like live TV. We'll fix it in post. I can start swearing, we'll bleep it out.
Can you see my screen?
Yeah, we can.
All right. So I ended up making a little bow tie for my dog.
Oh my God. That's
Or if
adorable.
anybody wants to wear it, that's fine too. But I started off with this vintage tie I bought a while ago that had been sitting around. And I thought it was kind of neat because it said it was New Haven.
Yeah.
And I kind of just winged it. I didn't have plans. I kind of just went on and I sewed it together and it worked.
That's incredible. So now I have 1,000 follow-up questions. You're definitely better at conductive thread than I am. Two, like, where was the circuit testing part? Just for the sake of clarity, because you got a bunch of great images.
It was kind of in my head. It was kind of like, Lila, connect the negatives to the negatives and the positives to the positives. That's all it went on.
Cool, but there's like I would love to see. Yeah, that's exactly what you should do.
Like that thread is hidden, because that's another thing. Like I wanted it to be hidden.
Yeah, no, that totally makes sense. I wonder, is there a picture of it in progress where like the circuit is laid bare and it's not yet in a bow tie? Because I would have missed that. If I was taking pictures, I'd be like, I'm in the middle of this project, I'm not stopping. And I would forget.
This is kind of how I sewed it, but I'm telling you, I just kind of was like, all right, just make sure you're sewing the right ends to the right ends.
Okay, cool. Yeah, no, that totally, oh, there you go. Yeah, I see in the like middle left pictures where the sequins are. That totally makes sense. So you're able to just like connect that way and throw your conductive thread together. That's such a nice little project, all buttoned up.
How can I get out of that? All right, and then how do I make it so... Hang on one second, because my screen is weird.
Sure, yeah.
All right. There we go. So can you see it? There we go. There it is. So yeah, I don't know what to show you. Yeah, like there's a.
Oh, there's the sequin, and then there it is.
Yeah.
And they're nicely hidden behind the front part of the bow tie.
Yeah, and just mine is similar to Jamie's. Like the thread sometimes. I think it's the switch because you can see there's nothing touching that on switch.
Gotcha.
It's pretty clean.
Yeah.
So, yeah.
That's adorable. I love the pictures of your dog wearing it.
Now, but
yeah, don't wake him up. I don't want to make you move the dog, but that's really cool.
Yeah. And I really wanted to get the tufting gun going, and I left a piece of the tufting that I kind of got worked over there. If anyone wants to play with it, feel free. It's just a little piece of nothing that kind of worked. But I bought some real tufting backing, and it's stretched on there really tight. So I'm looking forward to getting it going. Ruby, did you get anything else going with the...
Here's your tufting piece, right?
Yeah, the sample that I kind of got working.
No, this is totally working. The back is really nice and neat. So it's really clean, straight lines. The tufting came through, it cut them on this side. So it was awesome to see the two of you working together on this to really make this gun into something that works. It'll be awesome to see how this develops as a skill, where we'll be able to see people like make their own bathroom rugs, is what I'm imagining this turns into.
How long did it take to make that?
That gun goes so incredibly fast, even on the slowest speed.
Yeah? Like I'm trying to like imagine this as time.
Yeah. Like that, you could probably whip that up in like less than 10 minutes.
You said whip it up, so it must be like a pretty easy, fast process.
And it's a lot of, no, the hardest part is like if the thread keeps falling out of the gun, because there's really nothing pulling it in. You have to have the yarn in a rig where it's just flowing smoothly with no interruptions whatsoever.
It's very particular in that, very, very picky.
Do you want to start like a fast carpeting team or something? Like some competitive tufting?
Speed runs.
I bought foam cones from Joann Fabric, and I stuck it on my drill today, and I took an entire spool of yarn and I put it in there, and it worked. I have 2 foam cones, and it worked. No, I'll show you them, and it worked. And I think it would work even faster if you and I did it together, because the part, we're gonna
get video of that.
We're gonna get it working.
We have a series on Instagram of several MakeHaven posts of putting things onto drills to have them do other things, and that was just like...
Oh, it's perfect. It would work.
That's how I clean potatoes. Yeah.
Yeah.
Oh, ground pepper for our guacamole party.
Just like you get like I'd call it like a toilet wand. It's not actually a toilet wand, but you can put it on a drill and then just put it in a bucket, and you can, speed clean a bunch of potatoes really fast.
That's great.
I want to make a machine that does it for you, I think. You know why? Because that's a great idea, but I am a very lazy person.
Necessity, what is it? Necessity is the mother of invention?
It is.
Right?
We've got a machine building class later on. It's going to happen. We can totally do this.
Some big brain ideas here. I like this.
That's right. We're getting there. Let's see. Ben, you want to show off the circuit playground just to like show what it is?
Sure.
Cool.
So I've successfully completed the step of procuring a circuit and done little with it, but Corey's been coaching me through what I might do. But I bought this circuit playground, which is a small chip that has on it a number of different, it has I think 10 different LEDs, it has a bunch of different connection points, both analog and digital. It has a thermosensor, which is what I wanted it for primarily. So it can take temperature readings, but it also has it has a small speaker on it. It can receive infrared signals, so you could theoretically control it with remote control. But my idea was to put this on the coffee cozy that I had made last week, and then it would be able to read how hot the coffee was, and then use the LEDs on here to somehow display that. But that'll require some coding that Corey will help me with. So.
Well, and it's totally, yeah. The code for that is a really neat process. Am I still? Are we upside down?
Yeah, I don't know what's going on.
That's all right.
Yeah.
So I'm pulling up on my computer the Circuit Playground Express, and it's a really neat platform. It's like built to be a learning platform, and the example of it up here has, oh, and maybe it's not up on the screen. We're trying to do some technical wizardry. But I can drop this into a Slack chat, or into the Slack chat, just so that you can see and sort of scroll through the, oh, I wanted to go to Slack. Almost there. Trying, launch Slack, MakeHaven. Okay, I'm dropping this into the chat so that you can see sort of what's going on, and we can process what what a Circuit Playground Express is. But it's a variation on an Arduino that is accessible, and it's got a bunch of things baked in. So it's a great platform for learning how to use all these tools and sensors and inputs and outputs without needing to like have wired them up or solder them yourselves, because you all just saw that can be at times frustrating to do the building part. So here it's bought pre-assembled, and then you figure out how to make the code work, which is a great starting point for lots of projects. And so you've got this that we're all sharing too, but then you can pull up the Arduino IDE and you can do some coding here. And then the other piece that's really good is that in here there's a Microsoft Make, whoops, it was just under the thing that I wanted to open. There's this Make code system where you can do some like programming with blocks where you like slide things around. This doesn't work for all platforms, but Circuit Playground Express is a great starter because you can do this where like you want to say forever show the ring that's red, do that constantly, and then wait for 500 milliseconds, and then turn it blue, and then wait for 500 milliseconds. And that is fundamentally what you're seeing in that little projected tiny screen up there is the process of coding. It's just block coding. So instead of writing text where you can have punctuation errors and syntax problems, this is dragging around little sections that you can align to make it do what you want. And so this is like a preview of where we're going to get to with coding. But for right now, it's just good to see that that is on the horizon. And in the meantime, just because I'm familiar with it, I would totally do this with Arduino code, which is hard to read on that scale. Let's see, can I make these bigger? Maybe, maybe not. Oh, it's trying. It's trying. The computer's getting there slowly. But with code, you can drive it in the same way. So code would just be another way to make it happen. The blocks have code hidden in them. They're still code. They're like code chunks that you can move around in groups. So those are all different processes that can work, but it's a great tool to get all of that to happen together. So it's a neat way to sort of blend the circuits. The Circuit Playground Express is great because it's got those extra large openings that are like almost too big to solder a wire to, but they're perfect for running a needle through for sewing in sewable pieces. So increasingly they're starting to use those for wearables is sort of why they have the big openings. But yeah, it sounds like we've got lots of great things going on. Anna, did you have anything that you wanted to share, or are you taking it by? There's plenty of good reason. This was a tough week. I feel like the wearables was not an easy go.
Unfortunately, like I have this cold that just keeps coming back. I don't have a fever, but I'm really worried about coming in and touching public spaces, so I didn't go down and get the supplies for the LED sequence, which I did have an idea for, and I had a plan, but my goal is to get down there on Thursday and actually like pull it together.
Yeah, that sounds great, and hopefully you got to see lots of good examples of things just right now that will hopefully give you pointers for whatever it is that you're headed towards. There's tons of good pieces to learn from what we saw, and I really like the show and tell part of the class just because it gives us the opportunity to process. Usually it's by screwing things up that I have learned the most, and so by getting to share with each other the cool things we made and the things that worked well and the things that didn't work well, I think we're all learning together more about how to make it better the next time or how to use it in the next project in a smarter way, right? The fact that we're doing this together, we get to lean on each other and learn from our shared experience is a really helpful and powerful part of the course. So yeah, look forward to seeing you healthy and well on Thursday, Anna, and then we'll get you into the wearables world. And then also, I'm real excited to see everybody get started on metalworking projects. Does anybody have some ideas for what they want to do? Some thoughts? Suggestions?
Yes.
Yeah.
Yeah, I've been wanting to make chopsticks for a really long time. And that's probably like really simple. But I love to eat, and I often eat too fast. And I was like, wouldn't it be cool if I could make my own utensils? And I've spent more time than I'd like to admit looking at chopsticks on Etsy, and I was like, I could make my own. So that's what I'm going to start with.
That sounds great. And that's exactly a good example of where I would do some research and make sure that aluminum is a totally safe and fine to eat with tool. But it makes sense that it would be. So I would, yeah, but that sounds like a great one. You're going to be...
I had to do some reading on like the different alloy types, and I think I ended up with I think it's called 316. So...
Sure.
Yeah.
316 is a stainless steel. Cool. So then that sounds like you're doing the right things, because silverware isn't usually silver anymore. It's all stainless steel, stamped and bent into place. So you'll want to take a look at that and see if you need to do any surface coating once you like get it shaped into the form that you want. It would be good for follow-up. Awesome. Anybody else have an idea for a project they want to do? Yeah.
I want to make an aluminum box.
Jamie wants to make an aluminum box.
And a solar rack for my solar panels.
And a solar rack for solar panels. That sounds exciting. Like you could.
Yeah, all aluminum.
All aluminum. It's nice and light.
Yeah.
It's a good way to go. You can get an aluminum angle at Home Depot or Lowe's for super reasonable.
I need a C or U channel that's 10 feet long. That's aluminum.
Come on up. Aluminum C channel is what? Yeah.
Yeah. Some people call them U channels or C channels, but I need one of those, and I need it 10 feet long, and I've found it very hard to source that. I went to Home Depot, and everything is like 8 feet, 96 inches, but I'm putting on two 330 watt solar panels that were actually cheaper than getting 100 watt from like Renogy or Amazon or whatever. And there's just more juice I can get from them. So I need to run long C channels, and I need to custom make the rack because I don't want to spend $500 on a rack. And I just, I want it to be very stable, very light, and it won't rust. Aluminum won't rust. So that's what I'm going to do.
Cool.
And if anyone knows where to source C channels or U channels where I can get like a 16-foot piece, that would be great. Thank you.
Yeah, that's a great project. I would see it. So yeah, it totally makes sense that that's what you want to do. If you can do it with multiple split runs and then just have them like butting up against each other, it might be worth it to try and consider, because the extrusion process sometimes does have manufacturing limits. And so if you try to buy just past the like normal manufacturing limit, it may be way more expensive when you're like, it wouldn't be that hard to put two next to each other. And it's totally a per situation choice.
I think I might have found a place, but it would be like $50, which would be $10 more than a 8-foot piece at Home Depot.
Okay, gotcha. So maybe you found a spot, just to repeat, you might have found, and it might have been long enough, and the price might be right.
Yeah,
but you got to cut it down. And if everything works out the right way and you're happy with what you bought, that's the big thing. So, cool. But sometimes, like if people need a 9-foot sheet of plywood, right? That's where it comes in 8-foot sheets. You got to figure out a way to make that work. So, yeah. Anybody else have an idea for what they want their project to be? Just while we're spitballing.
I'm going to attempt to make a bell. We'll see how that goes.
Oh man, that's exciting.
A metal bell that actually rings, but I'm not sure how that's gonna go.
That feels like a great scoped project for the metal shop for like first round, because it's definitely going to be harder than it sounds like it should be. But I think you're totally in pursuit, because it's a few simple parts. You can make sense of what it is. Like at its most basic level, you could get an eye hook, put it through, and then a dangly part in the middle, and you're good to go. If you wanted a terribly ugly bell, I'm sure your standards are higher than that. But it's exciting to see, like, I'm really curious for what this bell's going to be. And I think that picking a project and letting it last for 2 weeks in this metalworking time is totally appropriate. Don't feel like you have to rush through and get too done over the course of time of these 2 weeks, because things in the metal shop with all the research and then sourcing materials can take longer than you'd expect. So, cool. Anybody else? Or do we think, or maybe we're good? Oh, you want to make a what? A knife? Ada said she might try and make a knife, which is very exciting.
Although also I'm wondering, we don't have an anvil, do we?
We do not have an anvil.
We do not have an anvil was the question. Do we have an anvil? And the answer is no. Yesterday I did the metal lathe class, and this is what I made on the, wait, where's the camera's right here. So this is what I made on the lathe. It was a 1-inch piece of stock aluminum, and then over the course of several hours, it got turned down to a 0.875, it's 0.876 inches wide stock of steel. So it may have taken me, it may not look like a lot, but it's a very specific diameter of steel cut by me on the lathe. And so that's like a project that can take a while, a lot longer than you would expect. It's part of why I'm saying don't necessarily choose to build your own steel structure of something. It may take longer than you expect. But like a simple thing like a bell, a knife, frame, those are great projects for the metal shop to get started with. So, yeah. Ruby, do you have an idea?
Yeah, I kind of want to make a replica of some earrings that I have already, and I'm wondering, I don't know anything about the metal shop, but if I could work very tiny and like, is there a limit to that or something?
Oh, no, you can work whatever you want. I think it's just the sort of spirit of the problem is metal. And so if you've got tiny metalworking that you want to do, there's absolutely tiny metal stuff that we can make happen. You'll still need to polish probably and still need to clean, and that's still lots of metalworking tools. So that's totally in scope.
Corey, I was looking at the site, are we actually going to be presenting in 2 weeks? It almost looked that way.
Yeah, there was a thought.
Projects? Yeah.
Yeah, yes. And so also that's a good point. Thinking ahead, here we are November 1st, right? There's holidays coming up, and who knows what that means in time of COVID. But there is a break week coming up, the week that includes Thanksgiving, because you should, as much as we can, we should be with family. And do those things. That feels like an important thing to value in this class. And so just going forward, there's that. There's also, I think the main thing that I took away is I want to have a little time to focus and recollect. Right? We've been doing this sort of survey of the different areas of MakeHaven where we're hopping in, we're getting experience, we're getting exposure, and that's really been the focus from the code part, where we did Git and websites and portfolios, then we did woodworking, then textiles, and now metalworking. Those are definitely exposure sections. And so I think it would be good for us to have just a little bit more flexibility in this unit with the metalworking. One, to get the research and make sure that you do everything that you need to safely and get it done. But also to make sure that if you need a little bit of time to tidy up other things, that would be good to do as well. So it is a little bit more time over this section, so there's going to be a little bit more. And I think that ultimately what I'm going to encourage is that like you have a project that you're working on, and then even if it doesn't include it, you go in and you weld something. That'll be like the week 2 part. So that even if you don't plan on welding for your project, you just get a chance with the MIG welder and like making metal molten, because it warms the heart. It's good for you. So that's not really a second presentation, but it might be fun to just hold up your name welded into a piece of metal. So does that fit with what you were thinking, Kate? There's not really going to be a full second week of metalworking. So if you're trying to imagine what that looks like, that's the plan. Cool. But I think that's probably it. We should stop recording, and then if you have any more questions or things that you just want to chat about, we'll stay on the call. And then I'll be around if you want to troubleshoot any more or talk about plans. So cool. See ya.
Thanks, Corey.
Yeah, thanks, Ben. Have a good night. You all good, JR?